So far we have seen the first half of the first chapter. The next half, the second half of this chapter, is going to talk a little bit more in details about the SQL or the SQL language itself. Okay, we're going to look at some of the common statements that we can write in this language. So there are two types of statements, broadly, if you categorize. The first type is SQL or SQL DML statements, or data manipulation language statements. And the second category is the SQL DDL or data definition language statements. So you can use some of these statements to manipulate the data in a database, and you can use the others to work with database objects. Okay, although you may not be able to code these statements after reading these topics that are coming up, you should have a good idea of how they work, and then you'll be better prepared to learn the details of coding these statements when they are presented later on in the book. So that's the idea. We're just going to do an introduction sort of thing of what's to come. So when you are talking about the DML language, data manipulation language, we have select, insert, update, delete. So select allows you to select or display the data or from a table, or sometimes more than one tables. Insert allows you to input, insert data, update to modify, and delete to remove. Data definition is all about creating the database, tables, indexes, altering the tables and indexes, and dropping tables and indexes. So that's those are the two types of or two broad classifications. Now here we see a simple example of a statement that creates a new database. So create database AP. This will create a new database called AP. A statement that selects the current database is use AP. So you have to specify the database that you currently want to be using the use statement. And okay, the next slide here shows you how do you create a new table. So the command for that is create table, and then the name of the table, and then a whole bunch of details specifying the columns, what are the data types, what are the if it's a primary key, does it have auto increment, does it have a null or not, all those kind of things. And we're going to obviously see all this in detail later on in this book, but for now just know that this is the syntax. This is how the syntax look like if you want to create a new table in a given database. We also are adding a bunch of constraints here. We haven't talked about that yet, but you will learn all about it. A statement that adds a new column to a table. So say you have already created a table, but you want to add another column to it. You can do that by saying alter table invoices and then add balance due. So like you're adding this balance due column to the invoices table, and the data type is going to be decimal 9,2, which is a common data type used for storing currencies. So 9 is going to be the number of digits before the decimal place, and 2 is going to be how many after. So this is dollars and cents basically. Now a statement that deletes the column, the new column, would be alter table invoices, drop column balance due. Okay, so drop is often used to drop either a column, a table, even a database. So this is how you do that. A statement that creates an index on the table, create index, invoices, vendor ID index on invoices, and then you provide the column that you want to create the invoice for. You don't have to be like look at really memorize these syntax yet. This is just an introduction. A statement that deletes the new index, the drop index this. So this is the invoices base table. You can see that there are a bunch of columns: invoice ID, vendor ID, invoice number, all that stuff. A select statement that retrieves and sorts selects columns and rows. Selected columns and rows is would look something like this. So there's a few things going on here. I'm just gonna highlight some of the things. So this is you can look at it as in different parts. This is the select part, and this is the from, this is the where, and this is the order by. There are like 4 parts of this query. So the select part is going to specify all the things that we want to display. So here we have invoice number as one, invoice data. Some of the things are calculations, like for example, invoice total minus payment total minus credit total. So you can do arithmetic calculations like that. And then we are using as this is an alias, so balance due. This column does not really exist in the table, but we can add it like here, this is balance due, and based upon these the invoice total, payment due, and credit total calculation. So that's the select part. Next, if we look at the invoices, this is just specifying the table that we are working with. And then finally we have where. So where is another calculation, and it's a check. If this is true, if this whole thing is true, then invoice total minus payment total minus credit total, if that is greater than 0, only then display the results. And order by finally allows you to sort it, sort all your data. So here you can see invoices, the invoice date. So we are sorting by the invoice date. So that's all this statement is doing. The next statement here is an example of a join. So we learned this in chapter 4, that a join allows you to get data from more than one table. So in this example, we are collecting data from the vendors table and the invoices table. So again, we have 4 parts. In from, we have select, we have where, and we have order by. And within the from, we have something like join here. This is going to be, well, inner join, let's say. We're going to join these tables of vendors and invoices together, and we are also specifying based on what criteria should we join. So here it says vendors vendor ID. If it matches invoices vendor ID, then it's a match. And then we are also saying that, okay, you got a match, but is the invoice total greater than 500? This is another sort of a check that we are doing. If that's the case, then okay, fine. So we want to display the result, but we only want to display these things here: vendor name, invoice number, blah blah blah. So like these 4 items. And while displaying them, make sure that you order them by vendor name, and if the vendor name is the same, then you go ahead and order that by invoices total, and it should be ordered descending, not ascending. So these are a whole bunch of different things you can be specifying. So the invoice total should be ordered descending, not vendor name is still ascending. So these are a whole bunch of things you can be specifying while writing the statement, and we're going to see all this in detail later on. Okay, so there are a few key terms to know about SQL that we have discussed so far. So what is a query? A select statement is commonly referred to as a query. Okay. Now, what's a base table? Base table would be something that exists in your database. For example, the invoices table that we saw would be a base table. What's a result table? A result table or a result set can include calculated values that are calculated from columns in the table. So you could when we were looking at the previous slides, there was a balance due column, and that was calculated based on some of the existing columns in the invoices table. So that is an example of a calculated value. And in a result table, you could have the straight up tables that exist in the database, straight up columns that exist in the database base table, but also in addition some calculated values as well. So that's the result table. So I already explained what a calculated value is. And then we talked about joins very briefly, but joins basically allows you to combine data from 2 or more tables into a single result set. Okay, so unlike the query, which which only gets data from one table, you can do a join query which would get data from multiple tables. The most common type of join is in the inner join. This type of join, the inner join, returns rows from both tables only if their related columns match. Okay, so if where we saw the vendor ID and from the invoices table and the vendor table, if they matched, only then return the values. That's an inner join. And what's an outer join? Well, an outer join returns rows from one table in the join, even if the other table doesn't contain a matching row. So outer join doesn't really care about this match taking place. So oftentimes it's a big output in an outer join, whereas inner join is more specific, and that's why inner joins are more useful in many more cases. Like people find that, like, okay, I need an inner join, not an outer join right now, sort of thing. So that's these terms. You can use the insert statement to add rows to a table. This is an example of adding a row to the invoices table. We are using the insert into statement, and we're specifying the table name, then we're specifying what columns we want to add the values into, and then we're specifying the values. And executing this statement will insert a row into this invoices table. If you want to update of certain values for a given row or a record in a table, we can use the update statement. The update statement is used to change the values in one or more rows of a table based on the condition you specify. So here we are saying update invoices, so that's the table name, and set credit total is equal to 35.89, where invoice number is equal to this. Okay, so if the invoice number matches, then change the value whatever it was to this. Okay, this is an update statement. Another example of an update statement is going to affect multiple rows. Here's an example again, where the term ID is equal to 4, set the invoice due date to all this date, add invoice due date, comma, interval 30 days. So what's this going to do is it's going to add 30 days to the existing due date if the terms ID is 4. Okay, so here's this is a couple of ways or examples of how you can update existing values. You can use the delete statement to delete one or more rows from a table based on the conditions you specify. Say you want to delete a value, so or a row. Let's say what you do is delete from invoices where invoice number is so and so. So this will get rid of the row. A statement that deletes all paid invoices from the invoices table. So you can also delete multiple rows in one shot, like this, where you say delete from invoices where invoice total minus blah 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 is equal to 0. So we are specifying this condition, and if the condition is satisfied, just delete that row. So this is these are the way you would get rid of selected rows from a table. Let's take a look at two ways of writing a select statement that does the same thing and are syntactically correct, but one of them is easy to read, the other one is very difficult to read. The ability or the property of code readability is a very important one, and we should all try to write code that is easy to understand, because every line of code is read far more than it is written. It's probably written only once, but it might be read 10 times or more. So we have to make sure that it's easy to read. The first example, you can see that there is no capitalization, there is no indentation, the from clause is somewhere in the middle, the where is somewhere in the middle as well. It's really hard to read, right? And the second example, if you're looking for the condition, for example, what condition does this work on, you just know exactly where to look. Your eyes will directly go there. It's the where clause. And you can just see that, oh, invoice total minus payment total minus credit. Okay, this is the condition for for the select statement. So it's a much nicer way to represent the same idea. It takes a couple of lines extra, but I think it's totally worth spending the time adjusting it. So yeah, this is we're going to give you some more guidelines on how to write SQL statements in the upcoming slides, but this is an example of what would be considered as difficult to read versus easy to read. Here is the way you would write comments while writing your SQL or SQL queries and commands. So here you can see that the first example is a multi-line comment. You can see the author and the date are are wrapped within this slash and the star, and that tells the interpreter that MySQL interpreter that this bit is a comment, so you can just ignore it, right? You can also do single line comments, and this for single line comments, the term that you're going to use is the double dash. If you put those two dashes, this whole thing is a comment. And similarly, if you want to do multi-line comments, you can do this is a comment. Okay. So obviously the computer is going to ignore the comments. The comments are only there for explaining the code for humans, right? Next, let's take a look at some coding recommendations. So the first one is capitalize all keywords. So capitalize all keywords and use lowercase for the other code in an SQL statement. Okay, so these two kind of go together. Next, separate the words in names with underscores. Okay, so for example, invoice underscore number. Okay, separate the words in names. If you're used to Python programming, the convention in Python is also to use underscores to separate two words, and that's the same thing here as well. We use underscores. Start each clause with a new line. So where each clause means like the where clause or the from clause or the order by clause, those should be started from a new line. Okay, break long clauses into multiple lines. There's no harm in actually separating even if it's the same clause, which you can just break it into multiple lines. For example, if you're joining a whole bunch of tables together to get your data, you may want to separate those that one whole big thing into multiple lines to make it easy to read. Indent continued lines. So say you at the base indent layer level, you may have just the select, the from, the where, and the order by, but anything that is inside those clauses should have like a level of indentation, an extra level, a tab maybe. Use comments only for code that is difficult to understand. Okay, so over usage of comments is actually not a good thing. You don't want to, like, oftentimes what happens is this is just what happens in the industry oftentimes, that you may have a whole bunch of code and there is like a lot of comment there as well, legacy code, let's say, and people are maintaining the code because the code must work, right? Like if the code is not correct, then the system won't work. So the code is oftentimes correct, but the comment, people often many times do not go back and actually update the comments. If you make some changes to the code, oftentimes the developers will not take the necessary step to actually go and update the documentation as well, and that leads to incorrect comments, and sometimes the comments do not match what is happening in the code, and that just confuses the developer. And usually, like, if the person just read the comment and not the code, then they may have a wrong impression of what is going on in the code anyway. So it's important to have correct comments and correct documentation, very important. So if only if it is really required, you can, you will know when to write comments. Like if the code is so complex that you're afraid that when somebody reads it, they're not going to get it. So you probably want to write a few lines to explain what is going on, but it's not like a default thing that you should always have comments going on. Make sure that the comments are correct and up to date, as I said. Okay, now line breaks, white spaces, indentation, and capitalization have no effect on the operation of a statement. This is important to know. If you're coming from a Python background, for example, in Python, indentation actually has an effect. If you do not indent your for loop properly, it's not going to work, for example. So does line breaks and white spaces and all that. So even capitalization, right, have effects in programming languages, especially like in Python. But in MySQL, you do not have, these things do not affect the actual execution, but we try to write our code in a nice way so that it is easy to read. But remember, these things do not have an actual effect in the execution of the statement of the operation. In this course, you're going to learn how to use SQL from within the MySQL environment. But as we talked about before, there are also these application servers and web servers that are present in the whole picture, right? So SQL is commonly used from application programs as well. And these application programs, as we talked about before, are actually written in languages such as PHP, Java, or C#, .NET, etc. Sometimes they're also written in Python. So if you're writing an application software to and you want the application software to actually be able to get data from the MySQL and store data into MySQL, to have the ability to interact with that MySQL database server, you kind of may need to work with a few additional layers. Okay, so we'll just have a brief discussion about this, and then so that you have an idea of how this usually is laid out. So to work with a MySQL database, an application uses a data access API. Okay, yeah. So for example, PHP uses the MySQL API. So this guy here, MySQL API, or PDO, is the new one nowadays. Java uses JDBC, this API, and .NET languages use the ADO.NET API. So a variety of different languages would have their different APIs. Python, you may use Python MySQL connector, that API. So where each language will have its own API. API just stands for Application Programming Interface, which allows an application to interface with something else outside. Oops. And then we have a Java driver and a .NET driver as well. And the Java driver is going to allow this JDBC connector to work with MySQL. So some programming languages include a piece of software called a database driver for the API that it uses to access MySQL. For example, PHP includes a MySQL driver for both the MySQLi and PDO APIs. As a result, you typically don't need to install the database driver when you use PHP. Some programming languages don't provide a database driver to communicate with MySQL database. For example, Java doesn't include a MySQL driver for the JDBC API. As a result, you typically need to install a database driver such as the connector/J driver before you can use Java to access MySQL. And the same thing is true for .NET driver. Okay, cool. Okay, the two commonly used MySQL drivers are connector/J and connector/.NET. Connection/net. Terms to know about accessing MySQL data. We discussed most of them. Data access API. You're going to need an API if you want to interact with MySQL through a programming language. Okay. A MySQL API for PHP, PDO API for PHP, excuse me, JDBC API for Java, ADO.NET API for .NET languages, and also database drivers, a common term for all those drivers. The Java driver and the .NET driver, etc. Here's an example of PHP code that gets data from MySQL. Now, just remember, we're not teaching PHP here. This is just to give you a very high level kind of an idea of how it works, how it kind of looks. But this, so just to give you a general idea here, when you're writing PHP code, it would start with this, it'll start with this less than symbol and then question mark and then PHP. This is the start tag for PHP, and then it ends with this tag here, question mark and then greater than symbol. So whatever's in the middle is PHP code that can be put on some sort of a website. Okay, now if you don't understand anything here, that totally fine, don't worry about it. So here I'm just going to explain in general what's going on. So we are creating a few variables. The first one is this $query. This is a string variable, and it is just contains an SQL query. So anything that is, you see this highlighted stuff, this is just the SQL query. As you can see, this is a select query. We got a bunch of different clauses going on. We have a few more strings here. DSN is MySQL host is local. This is just the database connection details, and then you got the username and the password as well. Okay, and then we have a try and catch going on here. So try catch is exception handling. Basically, if something goes wrong in the try block, it will be caught in the exception block and processed. That exception might be processed here. So this allows you to kind of gracefully handle some problems with the connection. If let's say the server is down or the connection is kind of dodgy, you may be able to just get around without crashing the program. So here what we're doing is we're saying try to create a new PDO object. So that one is a PHP data object or something like that, and then and you pass in these values, right? DSN and the username and password. So that will actually create an object of type PDO, and is this $db is going to be pointing to that. Okay, if things go wrong, then show us some error messages, etc. But if things go okay, then move on to the next part here, which is that the statement is equal to then we are using this db, and we are saying that prepare this query. Okay, we're going to prepare for execution. Okay, that's the first step. The second step is to actually execute. So this prepare, I think, is a function inside, or a method inside the db object. I mean, this arrow notation that's what I think is doing. It's calling that method inside the db object. And here we are calling the execute method inside the statement object. And then once the execution is done, we can then say statements fetch all method, and the fetch all method is going to return all the rows. So all the rows are going to be stored in this rows object. Okay, so this is how you can use PHP to interact with the database server. Okay, and PHP has a whole lot of it. It's a full-fledged programming language, right? Like Java is a full-fledged. Similarly, you can also do things similar to this in Java or .NET or Python or any language that's out there, or not any, but many languages that are out there. Okay, cool. And PHP code that gets data from MySQL. Okay, so this is the remaining of the PHP code. So, well, this this is HTML, but then we have inside the HTML we have a little bit of PHP here. So what we're doing is we are running a for loop, and anytime we for each of the row in the rows vector or rows array, we are going to display the vendor ID and the invoice number. Okay, again, as I said before, this code is going to look really like cryptic and all, because there's a lot of symbols going on, especially when you put PHP inside HTML. It looks very messy, especially if you're not familiar with PHP. So it may not make sense, and it's totally fine. Actually, you don't really need to understand what is going on in the code. This is just to give you an example. Um, Again, as I was saying before, you can do the same thing in Java as well. Java code that gets data from MySQL looks something like this. The idea is very similar to PHP. So what's going on is here we are creating a query string query, and we're putting all our like SQL command here. And then we also create a DB URL string. So this is going to help us create actually the connection between the database server and our application program. We also need to store the the username and the password, etc. And then what we do is we try to create a connection object using the driver manager and all that. You're going to if you want to use Java, you kind of need to install a few things, right? You must install a database driver, and to do that you can download the jar file for the driver and add it to the libraries that are available to your Java application. And so there is some like setup involved, but it's only a one-time thing, so and it's not that hard, so I'm sure you can do this. But so as you can see, like you might be learning Java in a different course, or you might be learning PHP or Python in a different course, but doesn't matter whatever language you choose, you definitely need to know this SQL to actually do the work, right? In this whole thing, the SQL is really important. This is where you're specifying all the table names, or the whatever the query, the whatever's going on. So that's why this is what we are learning in this course. Okay, but to actually make applications using this, you are going to need to also be able to write code in some other language that can use the SQL to interact with database servers. Okay, so just keep that in mind, right? Like SQL is a part of this whole story, right? Okay, so this is the second half of the Java code. In this slide, it's not really much going on, except here we are actually just printing the vendor name, the invoice number, and the invoice total that we got from the previous slide SQL statement. This is also the last slide of this chapter, so I hope that you guys got a nice overview of the chapter if you listened through the whole thing. I did my best going over the details of that are written in the textbook with respect to each of the slides. Now, if you want to get a full idea, of course, if you want to get every little detail, you will have to read the book. I definitely didn't cover every single thing that's in the book, but I think I might have covered most of the important material. Okay. All right. That's the end. See you guys in lesson number 2, chapter number 2. Okay. Bye.